Good evening, friends. Welcome to Eason Academy. We are discussing about C programming as a part of embedded system programming. This is session 12. We are continuing our discussion on storage class variables. And in the last session, we have discussed about two types of storage. One is register and memory. Okay, that's the way you should break it down. Register and memory. Okay. Where do I store my variable? That's the question. Where do I store? I can store on register or memory. And then we have a question. Where do I store on memory? Local. That is temporary. Or static. Permanent. The local is also called auto. Actually, it's actually called auto and static. Auto and static. The auto is temporary and static. We'll discuss about some more points that we discuss all those things. So there is one more class. See here. That's how it goes like this. So memory storage store variable. Two classes. One is register. Other one is memory. In memory, there are two types: auto and static. In auto, it is temporary. It is always local. Local to function. Local to. When I say local, local to function, that's the meaning. So when you get out of the function, that is gone. That is gone. Now static has once again two. Static can be local or global. See, there is a confusion here in local, but please understand static is permanent. See, this is a no, don't get confused. See, don't get confused with local and static. See, it can be local auto or local static. Local auto is temporary, but local static is permanent. So local is not auto. This is all the confusion we have to remove. Now global. What is the difference between global and static? Access within function. Global, access by all function. That means that if you declare outside static char x, if I say main function, and I say x is equal to 5, I have another function. You are calling function 1, test 1. The test 1, I printf %d, comma x. You will get 5. You will get 5. Correct. Yes. Local static is permanent, but can be accessed only within the block, not outside. See here. If I do here, the same thing here. If I say here static, I don't declare here. I say static char x. This is also static. But if you print here, system will say, I don't get x. We'll see that. Let us see that immediately. That's the way you will believe it. Okay. What you see is a belief. Now I say that I put here static char x. I say x is equal to 5. I say test 1. I call. Remove all of them. Right? So we have a function called test 1.
Sir, screen is not shared.
Oh, thank you. Thank you. Sometimes, how many times I do that still I. Thanks, thanks. I want you to see the programming I'm writing. That's why I'm always writing now. Otherwise, I would have shown you the written program, that which I don't want. I want you to, if it takes some time extra, I know that. But I want you to see that the time when I'm spending the typing, that is the time for you to watch and think. Okay, if I show the full program, time is saved, operation success. But patient, you know that. You don't understand, which I don't want. I know all the reasons why I'm typing. If somebody thinks that why Balaji is wasting the time on typing, I'm just giving an explanation. Same thing, what I'm writing on the board, I can show you on the PPT. Why I'm not showing the PPT is very simple. If I make one PPT, I can show it for all the batches. Why I'm writing, wasting my time on writing. The problem is when I write on the board, you exactly think on the same way what I think. Okay. So your understanding will be much more than what I do it on the PPT. That may say I may save a lot of time, but ultimately you don't understand, which I don't want. I've done a lot of research, man. This 30 years, I've done a lot of research on these methodologies. Even though it's still I'm perfecting. I'm not trying to say I'm the great. I'm learning slowly to how to teach online. This is very new for me. Every batch I'm improving myself. So even the people, those who are attending my first batch, they're attending now, they will feel a totally different Balaji now than the first batch. Okay. So I keep learning. That's I never stop learning. See here 5. See, I put a static. Now I can copy the static here and put it here. Understand? Now I compile it. See, X is undeclared. See that same thing, same static, but this static is X is within local. See, this is what I'm trying to say. Don't get confused with static and global. Static, this is called static within a function that is called local static. This is called global static. But now I see one more thing. Now, if I see here, what will be the answer? Can anybody can guess? Now, what will be the answer if I compile it? I've declared global static. I've declared local static. I'm printing here percentage X. I want somebody to give an answer.
5. 5.
5. Okay. Now let me compile it. Let me compile it and see it. So first of all, compiler did not give error. That means this is as per C, this is acceptable. As per C, this is acceptable. Okay. So I can declare a variable in local static and global static. But when I'm executing the program, yeah, I got three answers. I got 0, I got 5, and I got garbage. Let us run the program now. I got 0. Somebody has given an answer 0 is correct. I'll explain to you why. These are all things I'll explain. That's the trick here. I'll explain to you that why it is 0. Okay, that has been understood very clear. There are something called very speciality of static. All the static variables are initialized to 0. Please understand. All the local variables are not initialized. Auto variables. So see, we should never get confused. Okay. Now let's see here. I do here another printf. Printf percentage D, comma X. This is the first X. This is the second X. Let's give a space. After test will be second X. Okay. Now let us do the thing. What I'm getting now. I get 5-0. Let me remove this. Let me remove this. Okay. I forgot to put a semicolon. Okay. It will print 2. It will print 1 here. It will print 1 here. I have not declared anything here. Now I see here what I will do then. 0, 0. Both are 0. So whether it's a local or a global, when I say static, it is getting initialized. Understand? The moment I say static, but I remove the static here. See here. I remove the static here. The same thing, I remove the static here. Yeah, I'm doing now. Now I'm doing now exactly the thing. Now I'm doing the same thing. I know that your question will come next. That way I'm happy that I could be able to guess you. Yeah, garbage 0. Let us see now. But of course, it's sometimes it gives 0. Don't mistake. That is not because of it's the garbage itself. This can be 0. Na? Let me run this. Let me run how many times? Let me see that. Let me try to give some other variables here. A, B, C, D. Let us see now how he is doing now. That's a problem. I don't. That's a problem now. Sometimes it gives 0 itself. So now the garbage itself is becoming 0. The stack is 0. I'm not able to clear the stack. Maybe I may call the function test here. Then I call X. See here. Let's see now. That means that somebody is using the local variable. Then I'm using it. I could not make it to garbage. I could not make it to garbage. No, if I initialize some value, then it's waste. Then it become a. I don't want to initialize. I want to show you that how that garbage value is coming. It's not showing now. I'll show you some other time. Now the stack is 0 somehow. Because of that, this case, maybe I have to print the value of A. Let me see that. Why A? I should be able to make X itself. Once the stack is 0, A also may be 0 only. See that. Somehow the stack becomes 0 or some error here. Let me find out. You're supposed to get garbage. Sometimes even we get confused because of the compilers. Okay. This need not be always. Now actually, as per the C rule, I supposed to get garbage. Now the 0 is also between 0 to 255 the garbage. Okay. Understand? So let's go back now. Let's go back to the board. So please understand this local auto local. This is in stack and that is uninitialized, whereas static is initialized to 0 if you don't initialize. If you initialize, that value will come. If you don't initialize, it uninitialized, all the variables are 0 here. It's a local or whether it's a global. Understand? So now we have discussed about 3. That is, we have discussed about 3. Register, auto, static. And in auto is always local. Static can be local or global. So when I declare any variable above main, understand, if I declare any variable above this one, static, above main, above the function, then that is always static. That means that a global static. Only in local, if we declare a variable char x, it is understood auto. That's why they given a name called auto. If you wanted to make a static, you should explicitly tell that static. Otherwise, it does not. But whereas in global, you do not have to mention static. You just say char x. It is assumed to be static. I'll explain later about all those other things. That is on the memory usage. I'll explain to you that all the thing of stack and everything. Memory uninitialized part. There's something called code segment, data segment, BSS, heap, and stack. These things I'll explain to you that on C memory management. This is called storage class. Don't get confused between memory management and storage class. Clear now. Now there is one more storage class called extern. So if I run a program, if I write a program now, char x int main, char x is equal to 100. That is fine. You have been allocated a memory location on the memory. Done. And this is local to the function. So that is allocated to the stack. I say now char x I say x is equal to 5. Now what happened? This is outside the function. So this is static, understood. This is allocated here permanently, not in the stack. It is allocated here permanently. And I put 5 here. There is a trick here. I have a file called, in the C it is possible. I have a file called test1.c. I can run a function here called, I can call a function called add. See here, I'm calling a function called add. I have another thing called char y. And I have a function called add. Right. This is a file called test2.c. To understand, I have two files, test1.c, test2.c. I have two files. Now, when I compile this, I get a binary file, test1.o. The O is called object file or binary file. Okay, test1.s means ASM file. So .c means C file. .s means ASM file, assembly file. .o means binary file, or we also call this an object file, or both are same. Now test2.o, but this will give you error. Am I right? Because you don't have a add function. Am I right? But compiler will not give error. There's one more steps are there in the compilation that also has to be explained. That is called, we have already discussed, preprocessor. Where the last class we discussed how the C is expanding the include file or as defined or macros. Then it does compilation. Then it does assembly. Then it is called linking. These two object files are linked by a call linker. I'll explain to you that why linker and not. I'll explain to you later. That's all very important. Then we have to create a lot of things called library, how to create library and not. I'll explain those classes in the coming days. Slowly I'm going because we have a lot of people have gone to the next level. So for them, it will be very useful. Because these are the things generally will lift your level on the interviews and everywhere. And overall, you will understand things. Now what happened? When I do the linker, if I don't have the add function, the compiler will not give error. But the linker will give you error saying that I don't find the add function. But if I tell the linker, if I tell the linker, link, ln, let us assume, I give these two files, test1.2, test.o. The linker is intelligent. It goes and see that, oh, this guy is having an add function. Then it will create. That's why same thing when you're doing that printf, you don't get error because the printf is given by the another object file from a library. We will discuss about what is called standard library, what is called user library, and how to create the user library and not later. But understand that a library is an object file, already pre-compiled one. It's a pre-compiled one. They are getting linked. So there is a problem here. When I put char x here, both are x, both are outside function. The linker will give you throw error because x is already defined. You cannot do that. For that, if you're going to use a global variable in both the function, the same name, you have to say here extern char x. See here, that means that don't declare. If I say internally, x is equal to 5. If I don't put the extern, the compiler will throw the error saying that I am unable to find x. But if I have an extern char x, then I am telling the compiler, don't worry, man. It is defined by somebody else. Linker will take care. Suppose if I have defined y here, okay, I've told the compiler, you don't worry, linker will take care. But when they come to a linker could not able to find x in the other one. Linker will give error now. Understand the difference between compiler? Compiler will give you that if you don't define. But by telling extern, so please understand the differences. When I say register, I told the compiler define the variable in register. Am I right? Done. When I say that static char y, I told him define the y inside the permanent memory. Yeah, the other one, it will say that you are not declared. The other one, it will say unable to find. Okay, we'll see that. We'll see that next. You're right. Let us stop here. Somebody has asked a very good question. Let us stop here. I don't know whether I've noticed myself. Thanks, thing. Let me remove that. Let me remove that here. Let's remove all of them. Let us call it as a now int x.
Sir, screen share.
Thanks. This guy is not doing automatically. Somewhere I have to do that. Okay. Now I say x is equal to 6. Printf %d comma x. All right. Let's write a small program. It's a very small. I declared X, I do that. We got X. Am I right? That's fine. Now I say int as a extern. Sorry, I don't declare this. Now I don't declare this. I say int X. What error I get? I don't declare X. See that? Error. X is undeclared. Am I right? X is undeclared first using this function. Okay, could you able to see that? That's a compiler error is giving. Okay. So compiler error this is. Note, each undeclared identifier is reported only once in each function. That's fine. So one error. Now, I say here, instead of this, I say here extern. Now I say here compile. See here, it's called undefined reference. See, understand here. Previously, when I don't put extern here, when I don't declare it at all, the compiler gave me the error saying that undeclared. Am I right? Error X is undeclared. Okay. Whereas when I am telling that extern, that guy is calling it as a undeclared reference. Okay. This is called LD return. LD is a loader. The LD means loader. The previous one was given the compiler error. Now the error is a link error. Understand? There's a big difference as we understood. So please try this. Actually, at home, you try this, you will understand why it is giving error. Okay. That if you have a build here, we can create a project and add multiple functions, files. That I'll show you next class when I have time. Otherwise, if I start taking now, it will take very long time. I'll be able to explain something else. So please understand, when I say the static, I am telling the compiler, you allocate on the permanent memory. You allocate on the permanent memory. Okay. Now, when I say that local within the function, I say that char X, then I'm defining in the stack. Okay, I'm telling you that stack. Once again, I'm telling you that I'm using stack, but still random. I'm not using the stack functionality. Stack functionality is different, stack is different. Don't get confused. Now, fourth one is I do that extern. I'm telling that don't declare but use it. Don't declare but use it. See here, what a very confused one. Don't declare but use it. When you actually the address will be given by only with this who, that linker. It's a very, very nice one. So there are 4 types. Understand? Auto, static, and register, and extern. There are only 4. Auto, always local. Auto is always local. Static can be local or permanent. And register is within the microprocessor. And extern is don't declare. Somebody is declared. Don't declare space for me. Somebody will give you and use it. Am I right? This are called storage class. Very, very rarely we use those. We use static quite often, but we don't use extern much often because we don't want to use any global variable referred. Okay. What is this range value for I don't understand. I'm not able to get you. What is the range value? What is the range value? Could you able to get me the, could you explain to me that thing? What do you want? I'm not getting the right of your question. Oh, that you declare. That you declare. Actually, that is not a thing. You say that register char, register int, register long, like that. Am I right? You will say that register at the, you don't you register is only a storage class. Your declaration type will be there always. Now I'll explain to you two more things before we complete today. That what is we understood very clearly. That's why I'm explaining now that. The two of them are all. One is called constant. One is called volatile. Okay. One is called random. One is regular. You can call regular. So constant means if I say constant char x equal to 5. If I say inside the program, now let us see. Okay, let us see what is giving this guy. See, we're getting error. Assignment of read-only variable. That means that when I say
Yes.
constant,
The screen is not visible.
every time I'm doing this mistake. Man. Yeah, see that. See that int main constant int x5, x is equal to 6. Printf facility x. That guy is showing an error saying that assignment of read-only variable. That means that it's only read-only variable. Am I right? You cannot change. The compiler will not allow you to change the variable x inside. If I put the comment here, if I run the program, it's fine. Now I run it, I get 5. If you, as long as I don't change, now I say that, see here, int y is equal to x. Now I say print y. See, it's fine. Everything is fine, but the only thing is I cannot change the x plus plus. I cannot store the value. I cannot change and store the value x. That is wrong. Is it possible to change? It is possible to change. I say yeah, static mean you can change. Static is changed. See, when you put static here, static is not about constant. Don't get confused between static and constant. Static is only about storage type. Where I stored in the memory. It's a permanent memory or local memory stack. So if I do like here, if I do x is equal to 6, now this is fine. You will get x6. So static mean you can change. But if you do constant, you cannot change. So please understand the difference between static and constant. Don't get confused. Static is in the permanent memory, I can change it. It's a regular variable. Only thing is storage class is different. Constant is, I say that this is a constant. Okay. Now, is it possible for me to change it? Let us say now. See here, int and y. Now I say y is equal to and x. Understood? Now I put, sorry, not and y, star y. Sometimes we do mistake. Star y. Now I put here star y equal to 6. I'm not changing x. See, change, understand here. See here, I'm not changing x. X is still 5. But I'm changing only star y. But I'm printing x now. See what is the result. First of all, I didn't get error. I got only warning because I say here type def. I have to say that, hey, this is a constant, this one. I have to say that both left and the right side types are different. Constant int star. Oh, he says that you give me a warning. You are trying to change the constant type. That's anyhow, you cannot even, you don't even accept the, this one, my type, this one, typecast. He's not accepting my even typecasting. He says that still, he says that you are trying to constant qualifiers. That's wrong. But if you run the program, you'll get 6. See that? I put constant x6. I put printf x. I don't change x. The compiler will not allow me to change x. But I take the address of x. I take the address of x to y. I'm changing star y. Understand now? I don't see here. I change the address. Forget about this. I change the address of x. I don't change x. I change the address of x from the symbol table. I do the memory change. This is fine. No, so a constant can be changed. A constant can be changed. If somebody asks you the interview, is constant can be changed. See, what we discussed this class, the previous session and this session, will show you in the interviews that you are better off than others. But of course, you should be a good programmer. Please understand, this is waste. If you don't, this is useful only if you are a good programmer. Understand? This gives you the added value. But if you are not a good programmer, all these things are waste. The previous section and current section is useless. I'll explain to you very clearly. These two sessions are very, very useless. Yeah, you are changing indirectly. You are changing indirectly. Okay, you are not changing directly. So these two sessions are useful only if you are a good programmer. I repeat this point very clear to you. Out of enthusiasm, you are trying to learn so many things. The storage class and everything. No use. Please don't try to remember too many things in your memory. It's all waste. Provided if you do a good programmer, this has a lot of meaning. Please. Understand now. So a constant can be changed. So this is only in the memory. So a constant is nothing but in the memory. But in the symbol table, the system will say it's a constant. So later when you are using it, the compiler will check the symbol table, then it will not allow you to change it. But if you do that, indirect way it works. This and not you will not be using regularly. It's all very typical usage. I'll explain to you that sometime. I'll explain to you sometime how it is useful. Okay, that's a very, very tricky one. Okay. Now the next one is very important. That for embedded people. So far I discussed common for everybody, but generally for embedded people, that's a very important. That is called volatile. We always get confused between the volatile, two volatiles. Volatile in C program, other one is volatile memory. Volatile is an English word. Now, when I'm using the volatile memory, ROM is a non-volatile. Whereas RAM is a volatile. ROM is a non-volatile, RAM is a volatile. With respect to power. Okay, that is when power is not there, ROM will remember the storage. That will happen. But RAM will be volatile. When the power is removed, RAM will lose the data. Understand? That is with respect to power. Whereas this volatile is different. The C volatile is with respect to modification. That means that with respect to modification, that means that only C program will modify. Only my C program will modify. Others can modify. Understand? Only C can modify, others can modify. How? Let us assume that I declare a variable. See that I say that char star x is equal to 1000. That is address. I put star x is equal to 50. I put printf. I give a delay. For example, I give a delay of 1000 milliseconds. And I do some other program. I say printf %d, star x. So what happened inside the memory? I have a variable at 1000. In 1000 at address, I have stored the value of 50. 50 is stored at 1000. Am I right? $50 is stored at 1000. Okay. Now, after so much of time, I print, I'll get 50. So the answer will be 50. This is called non-volatile. Suppose after so much of time, if I print, if this guy printed 60, I don't access in between that memory. That means it's called volatile. Understand? Who will change that? That's a trick. That is because we have microprocessor to memory. That's what we discussed. But there are something called controllers. The controller is a memory mapped. The controller is a memory mapped. So this controller it's look for you, for your software, it looks like a memory, but actually it is a controller. The controller can change the value, maybe a counter. It may be a counter. You have initialized 50. After so much of time, that guy could have increased the value to 60. Or that could be the, let's say you have this one. What do you call? Moving object on a conveyor belt. On a conveyor belt, a moving object. This object is moving. And here there could be a sensor. You'll be counting. Now, within the time, there could have been 10 objects would have gone. Now 50 could have gone to 60. There is a problem here. What is the problem is, this guy, if you say like this, star x is equal to 50 and printf star x. Understand here, I say char star x. Understand here, I put character star x is equal to 1000. I've written star x is equal to 50. Now you go think from the compiler point of view. You view from the compiler point of view. Compiler thinks that, oh, you declared, fine, I declared here. You're right. You are right. You assigned 1000, correct. I'm also accepted. Now you've written 50 here. I'm accepted. But you have not changed. During this period from here to here, you have not, what you have not done? You have not changed the value star x, the memory location. For by chance, if that guy put the register in the local register or one, okay, if he has not erased, what the compiler will do, directly print from the local register because you have not changed. So compiler thinks that you change the value, you return the value 50, but you have not changed. So why I have to read from there? I can directly give it from a local register. That will be faster. So compiler thinks that he is doing a help. Compiler thinks that he is helping you by optimizing. So when I say that star x is equal to 50, I do the program like this: move R5, 50, store R5, 1000. Now the R5 is having what value? 50. By chance, within this area, you have not used the R5. Let us assume your compiler not used R5. The compiler thinks that, hey, the R5 is there. Why once again I have to read? If you read, I'll be having the same value only because you have stored 50, you are not modified. So same value will be there. So what happened when you do printf? He will print what is there in the R5. He will not once again load it. So he is trying to save your time of load R5, 1000. This statement will not take place. Understand? If you don't understand, ask me. This is very, very critical for every embedded engineer. If you explain this on any interview, you will get a job. If you explain this on any interview, this has to be understood very clearly. If you write a program, the compiler thinks that you have not modified the memory, so I am not going to do the load function. The load function will take so much of time. But if you say right here, volatile, you are telling the compiler, no man, somebody will change it. Somebody will change it. So what he will do, when he put printf %x, he will do the thing, load R5, 1000, and he will print. If somebody has changed this to 60, there are possibilities. There is something called multiprocessor. I have a 1 microprocessor. A memory can be shared by both. You also write, they also write. You also write, they also write. Microprocessor 1, microprocessor 2, there's a shared memory. They're called multiprocessing. That time you write here, that guy also write there. Can be changed. Or This memory can be a controller, register in the controller. That is the reason I told you that for embedded people, the most important thing is volatile. If you don't give a volatile, the C compiler may optimize as he wish. That is his wish. You cannot tell him that why it is. But so you are telling the compiler only one thing. Please do not optimize. Read it from it may take slightly more time, don't worry. Read it from the memory to register. Don't take it from the local register or don't do anything else. He may sometimes remove the code also. He may remove the code also. How do you know? That's it. The compilers are becoming more and more intelligence. Our man thought about it who, when. Dennis Ritchie thought about it so many years back itself, or something happened, he put a volatile. Everything has been taken care by the C language. Of course, they are changing. Now people are going to follow the latest C standard, C11 and all. Is it clear? Do you understand volatile? If you don't understand volatile, let me know. That's a very, very important thing. So there are two things, constant and volatile. Now, there is one more thing. In controllers, there are something called status registers. They are called status. And you can also find out read only. They are called read only registers. Please understand, this is not a memory. This is not ROM. This is a controller where it has a read only register. That means you are not supposed to write that. I should not, if you write that, something may happen. So we declare volatile. That is a register. So it is changeable, but constant. Int star x. Understand now? It's a volatile, constant. Volatile constant means read only. That's the way we are using it. In every, I told you, no? The volatile, constant, and volatile constants are very important for our. Now you can see that. Let us see that. Let me show you some of the registers here in the data sheet. The data sheet, you go to the data sheets. Let me see that they have some read only. Otherwise, I'll show it to you later also. So the three possibilities. Go and read the lecture once again at your home and it will be clear to you. Sorry. Now let us see the registers. Something interrupt. Let us see whether we have any registers called read only. They always write, see here, they are all read write and read only, but the full register I don't see anywhere read only. Let me check. Here they have read only and they are read write. That's fine. I want to see that full register is a read only. I think it's not there here. Let me see somewhere. I'll tell you. Please. Sorry, I'm not seeing that. Where in SPI? I don't see anywhere. Let me refer today. Let me refer some document and here there's some bit is read write. Not all of them are read only. Sorry, I could not see that. It is not available in this. Maybe I look at the ARM register and show it to you somewhere. Read only. So wherever you have a read only registers, we declare them. That's what they write here like this. R. That means that only read only. You cannot change them. That's called R. Otherwise, RW means read and write. R means read only. Sorry, I don't see that. Please. Okay, so things are clear today. What we discussed about storage class, and there are two types of memory access: constant and variable usage, constant and volatile. And most used one is volatile. And when you do read only register, you do constant volatile or volatile constant. But you should use int or char, whatever it is, that is declaration. This gives you only the type of access. So actually, next one is going to be the memory. The memory is called stack. And the code, data. Okay, that's called initialize. And it's called data. It's called BSS, uninitialized. Next one is called heap. So we'll understand all of them. What is stack? What is heap? What is BSS? What is beta and CS? I'll have one more class. I thought I'll complete on this session, but storage class took more time than I expected. Okay, that is fine. It's one thing we understand correctly than everything. So if you have any of the other doubt on this, you send to me a message in the WhatsApp. I'll try to change on next time. Or if you feel that I could explain something extra, I'll change on next people. So that is this one. Register, auto, static, external. This is storage class. Then we have a storage type, volatile and constant. And constant, volatile, constant. See, this is a very confused term now. Volatile constant, how can it be? This can be only possible in C. It can be volatile, it can be constant. How can it be? This is actually called, if you say it's a read-only register, that's all, you score the full mark. That's called read-only register. Because volatile means register, it's going to change. Constant means read-only. So read-only register, sorry. If I say volatile, read-write register. If I say constant, read-only. Constant means read-only. Volatile means read-write register. Volatile constant means read-only register. That's it. Okay, then let me stop. Oh, it's already very late. Okay.